It's about a star, the 10th brightest star in the night sky. It has a name that I'm not going to be brave enough to try and pronounce, but you might. Apparently it's become 50% brighter.
Since the earliest days when humanity first began studying the stars and constellations in the sky, Betelgeuse has always stood out as one of the brightest. This red giant of Orion has captured attention for centuries, thanks to its characteristic red hue and mesmerizing pulsations. But now, scientists believe the day they have long feared may finally be approaching. New research, combined with increasingly erratic behaviors from this star, suggests that the Betelgeuse supernova explosion could happen much sooner than anyone expected. So what are the signs and new research angles that point to this coming explosion? When will it take place? And most importantly, what effects could we feel here on Earth when Betelgeuse finally goes supernova? Join us as we explore how the Betelgeuse supernova may soon light up the night sky all over the world. Betelgeuse is one of the largest stars in the Milky Way galaxy. To put its size into perspective, imagine placing Betelgeuse beside our Sun. The comparison would be like putting a massive football next to a small orange. Scientists have calculated that if Betelgeuse were to replace the Sun at the center of our solar system, its sheer size would engulf everything all the way out to the orbit of Jupiter. In terms of mass, it's about 20 times greater than our Sun. Its massive size and deep red hue have earned it the name of a true red giant. Betelgeuse sits roughly 640 light-years away from Earth, nestled in the constellation of Orion. And thanks to its incredible size and unique appearance, you don't need a telescope to see it. Just look toward Orion on a clear night, especially between September and March, and you'll spot it shining like a glowing red cosmic ball in the sky. For casual stargazers, Betelgeuse might look like just another star. But for scientists, it's a cosmic mystery, a star that refuses to follow the rules. One of its most fascinating traits is something called pulsations. Imagine a star that seems to beat, in a rhythm, almost like a human heart pumping blood. That's what Betelgeuse does. Stars don't normally behave this way, which is why Betelgeuse has long puzzled astronomers. First, it was its enormous size and striking color. Then came its strange, irregular pulsations. Betelgeuse doesn't shine steadily like most stars. Instead, it swells and shrinks randomly, with its brightness rising and falling in unpredictable ways. Even more intriguing, these pulsation patterns are never constant. They're always changing. Scientists have recorded cycles lasting 185 days, 230 days, 420 days, and even as long as 2,200 days, each one creating a different rhythm in the star's life. Then came a moment that sent shockwaves through the scientific community. In 2019, Betelgeuse suddenly began to dim. This mysterious event, now known as the Great Dimming, lasted through late 2019 and into early 2020. 4 months, Betelgeuse lost a significant portion of its brightness, sparking speculation that the long-awaited supernova could be imminent. And since that time, the star's behavior has only become more unpredictable. Another key feature of Betelgeuse is its dramatic fluctuations in brightness. Sometimes it surges to become the brightest star in the night sky, outshining everything around it. Other times, it dims so significantly that it slips far down the list of brightest stars. These cycles of brightness don't follow a simple pattern. They can last from just a few days to several months, always keeping scientists guessing. Over time, researchers have learned that these changes in Betelgeuse's luminosity occur in repeating cycles. The shortest cycle lasts about 185 days, while the longest can stretch from 2,300 to 3,500 days. The reason behind this constant glowing and dimming lies deep in the heart of the star itself. Stars are essentially nature's nuclear reactors. Their light and heat come from powerful nuclear fusion reactions happening in their cores. Large stars like Betelgeuse burn through their hydrogen fuel far more quickly than smaller stars like our Sun. This furious energy production keeps Betelgeuse blazing, but it also means the star is racing toward its inevitable end. And beyond the reactions in its core, Betelgeuse's extreme changes in brightness are also influenced by conditions on its surface. With a surface temperature of only about 3,500 Kelvin, much cooler than the Sun, It produces that iconic red glow that makes it stand out in the night sky. On any given day, Betelgeuse often appears much less bright than it should. But these fluctuations in brightness and its unusual pulsations become far more concerning when you realize this star is nearing the very end of its life cycle. For quite some time now, scientists have considered Betelgeuse a dying star, simply waiting for the moment it explodes as a supernova. Red giants like Betelgeuse are very different from ordinary stars. Their distinct orange or reddish glow signals that they have entered an advanced stage of stellar evolution, where helium burning begins in their cores. Every star starts its life burning hydrogen at its center through nuclear fusion, producing the immense heat and light we see. But as stars age, they run out of hydrogen fuel. At that point, they begin fusing helium and eventually move on to even heavier elements like carbon and silicon. This process causes the star to grow much larger and change its color. Even our own sun is going through this process, though at a much slower rate. Billions of years ago, it was hotter and bluer, but over time it shifted into the orange star we see today. And one day, far in the future, it too will swell into a massive red giant, just like Betelgeuse. Here's what happens inside. As hydrogen fusion slows in the core of a star, the outer layers start expanding, making the star swell dramatically in size. Meanwhile, helium begins to accumulate in a shell around the now depleted hydrogen core. Within this helium-rich shell, a new type of nuclear reaction starts, known as helium shell burning. In this process, helium atoms fuse together to create heavier elements like carbon and oxygen. The energy produced from this reaction helps counteract the crushing gravitational forces trying to pull the star inward, temporarily balancing it out and fueling its rapid growth. But there's a problem. Helium shell burning isn't nearly as stable as hydrogen fusion. This instability can trigger sudden bursts of energy that ripple throughout the star. When these bursts occur, Betelgeuse expands outward, and once the burst fades, it contracts again. This cycle of expansion and contraction is exactly what we observe as the pulsations of Betelgeuse. Scientists have also discovered that the powerful energy from helium shell burning generates fierce stellar winds in red supergiants like Betelgeuse. These winds are strong enough to strip away enormous amounts of material from the star's outer layers. Over time, this mass loss reshapes the structure of the star and redistributes matter and energy across its unstable body. So how have scientists managed to piece together such detailed knowledge about a giant red star located over 600 light-years away? The answer lies in modern technology. Astronomers rely on a range of powerful observational methods to study Betelgeuse, and two of the most valuable are photometry and spectroscopy. Photometry involves carefully measuring a star's brightness over time, tracking changes in its luminosity. By observing how Betelgeuse brightens and dims in different cycles, scientists gain insights into the nuclear processes unfolding deep in its core. In simple terms, they read the star's outer behavior as a kind of code for what's happening inside. Spectroscopy, on the other hand, offers a much deeper look. By spreading out Betelgeuse's light into a spectrum of different wavelengths, astronomers can analyze its composition, temperature, and even its motion. Every time the star pulsates, its spectral lines shift and broaden, revealing hidden details about the physical conditions inside. By combining these two techniques, photometry and spectroscopy, astronomers have been able to unlock many of Betelgeuse's secrets. Photometry reveals the timing and patterns of its brightness changes, while spectroscopy explains the physical forces behind them. Together, they create a more complete picture of how this massive, unstable star lives and evolves. But even with these tools, the work doesn't stop there. To fully understand Betelgeuse's inner workings, astrophysicists also use sophisticated computer models and mathematical simulations, recreating its behavior to predict what comes next in the life of this dying giant. These advanced computer models use equations that describe stellar structure, enabling scientists to calculate the nuclear reactions and fluid dynamics happening deep within Betelgeuse's core. Thanks to these simulations, astronomers have been able to visualize both the star's nuclear reactions and its surface conditions in a way that was never possible before. But beyond the nuclear activity, another vital process is at play inside Betelgeuse: stellar convection. This natural mechanism transfers heat and energy from the blazing core all the way to the star's surface, creating a direct link between its internal combustion and the outer light we see. In simple terms, stellar convection is the movement of matter inside a star caused by temperature differences. Near the core, nuclear fusion generates immense heat, which warms the surrounding material. As this material heats up, it expands and rises toward the surface. Meanwhile, cooler material at the surface sinks downward toward the core, where it is reheated and rises again. This continuous cycle of rising hot plasma and sinking cooler gas is stellar convection, and it occurs in every star, including Betelgeuse. Whenever hot material from the core reaches the surface, it brings energy with it. Part of that energy is radiated into space as light, which means the star appears brighter whenever there's a fresh surge of hot material moving upward. But in recent years, Betelgeuse's pulsations have become increasingly erratic and unpredictable. Even the models that astronomers once relied on to predict its behavior suddenly stopped making sense. A dramatic example of this came in 2019, when Betelgeuse shocked the world by dimming more than ever before. After close observation using the Hubble Space Telescope and other powerful instruments, scientists discovered that Betelgeuse had essentially blown its top. A massive portion of its surface mass was hurled into surrounding space, in an event scientists labeled a surface mass ejection, or SE. This ejection produced a dense, cold patch of gas and dust that obscured our view of the star, making it appear much dimmer than normal. The event became known as the Great Dimming, and it immediately drew the attention of astronomers across the globe. For months, many feared the star was about to explode into a supernova, but instead, Betelgeuse gradually regained its brightness. Still, things were never the same after that. Betelgeuse's pulsation cycles, which had once been relatively predictable, were thrown off completely. Morgan McLeod, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, recently published a study that revealed just how much things had changed. For decades, scientists had tracked a 400-day pulsation cycle in Betelgeuse. But after the Great Dimming, that cycle suddenly halved to about 200 days. According to McLeod's simulations, the Great Dimming was caused by a convective plume, an enormous upwelling of hot material from inside Betelgeuse. This plume surged upward, forcing part of the star's outer layers to break away in the form of that massive ejection. McLeod and his team believe this violent event disrupted the star's natural pulsation rhythm, reducing it from the familiar 400-day cycle to the new, shorter 200-day cycle now observed. His explanation has been widely accepted within the scientific community, solving the mystery of both the Great Dimming and Betelgeuse's new, irregular pulsations. But while this discovery answered some questions, it raised an even bigger one. Are these signs pointing toward Betelgeuse's imminent collapse into a supernova? Could we be witnessing the final stages of its life right now? For years, cosmic models suggested that Betelgeuse still had at least 100,000 years left before it would collapse in on itself. That would mean plenty of time before its death. But new research has challenged this comforting estimate, suggesting that the explosion might happen much sooner. Some experts, including the well-known physicist Michio Kaku, have speculated that Betelgeuse's unusual behavior is a signal of its approaching end. A supernova, the cataclysmic death of a massive star, is one of the rarest and most awe-inspiring events in the universe. When it happens, the explosion is so powerful that it releases more light than all the stars in its galaxy combined, briefly outshining everything else in the night sky. In the past, Betelgeuse was often referred to as an orange star. But new research has revealed something extraordinary. Nearly 2,000 years ago, Betelgeuse wasn't even a red star, it was yellow. That single detail means that back then, it had just entered the stage of burning helium in its core. Fast forward to today, and Betelgeuse has already transformed into a massive red giant. In other words, this star went from yellow to red in only about 2 millennia, which is incredibly fast in cosmic terms. This rapid change shows us that Betelgeuse is burning through its helium fuel at a shockingly accelerated rate, much faster than astronomers are used to seeing in other stars. Edward Guinan, an astronomer at Villanova University in Pennsylvania, put it best when he said, This star always fools you. You think you have it and all of a sudden it changes. That deceptive, unpredictable nature has convinced many experts that we should prepare for the worst sooner rather than later. Adding to the urgency, a 2023 study, yet to be fully published, suggests that Betelgeuse has already entered the final stages of its stellar life cycle. At this point, its helium-burning process is racing forward far more quickly than before. If it took about 2,000 years for Betelgeuse to shift from yellow to red, it could take less than 100 years for it to move from red giant to catastrophic supernova. The research, led by astronomer Hideyuki Seo, indicates that Betelgeuse may already be wrapping up its carbon-burning phase. From there, it only has a few more steps, burning heavier elements like neon, silicon, and finally iron, before it collapses and explodes. While some scientists still insist the star may survive for thousands of years, a growing number of experts believe its end could come much sooner than expected. Why do supernovas always spell the end for stars like Betelgeuse? It comes down to the delicate balance between nuclear fusion and gravity. As long as a star has hydrogen to burn, the energy produced by nuclear fusion pushes outward, counteracting the crushing inward pull of gravity. But once hydrogen runs low, and later helium and other fuels are exhausted, the balance collapses. As the core struggles, pressure and temperature rise to staggering levels, forcing the fusion of heavier elements like carbon, silicon, and finally iron. But iron is different. Unlike lighter elements, fusing iron doesn't produce more energy, it actually consumes it. When enough iron builds up in the core, the star simply cannot support its own weight anymore. Gravity wins, and the core collapses in an instant. That collapse rebounds outward, unleashing one of the most violent events in the universe, a supernova. In that explosion, all of the iron and other heavy metals forged inside the star are hurled out into the cosmos. This is how the universe becomes enriched with the elements we see all around us today. The gold in jewelry, the silver in coins, the iron in skyscrapers, and even in your blood, all of it was created in the heart of an ancient star that ended in a supernova. In that sense, supernovas are not just deaths, but also births, the destruction of one cosmic giant paving the way for the creation of worlds, planets, and even life itself. So what would happen if Betelgeuse explodes during our lifetime? The effects on Earth would be profound. Supernovas eject their outer layers and cores at unimaginable speeds, unleashing enormous amounts of energy. The very first thing we would notice is an extraordinary brightening of the sky. In fact, cosmologists predict that the Betelgeuse explosion would shine brighter than our own sun and be visible even during the daytime. For a while, it would appear as though Earth had two suns, our familiar yellow one, and an enormous, fiery light blazing from Orion's shoulder where Betelgeuse once sat. But it doesn't stop with the light. Supernovas also release powerful shockwaves capable of obliterating anything in their path. If Betelgeuse were located inside our solar system, the blast would tear Earth apart without question. Fortunately, at about 640 light-years away, we are far enough that scientists believe we are safe from the direct destructive blast. Still, not every expert agrees we'd be completely unaffected. A smaller but cautious group of scientists warn that Betelgeuse's explosion could send radiation or energetic particles across vast stretches of space, some of which might reach Earth. If that happened, life here could become very difficult indeed, as our planet would be bombarded with harmful cosmic rays on a scale we've never experienced before. As a massive star, Betelgeuse going supernova would release deadly gamma-ray bursts, or GRBs. If Earth were to receive the impact of such radiation from a star this massive, it would affect everything on our planet. The very first thing to suffer would be our ozone layer. A powerful GRB could seriously damage it, exposing us to the sun's harmful ultraviolet rays. The ozone layer is the protective shield surrounding Earth in the stratosphere, made from 3 oxygen molecules. GRB waves can tear ozone apart on a molecular level, leaving Earth's atmosphere exposed to UV radiation and other natural dangers. With such exposure, deadly UV rays would strike Earth directly, impacting humans, marine life, animals, and plants alike. Humans would face severe skin effects and weakened immune systems, eventually leading to other complications. But the damage wouldn't stop there. beyond biological life, our technological infrastructure would also be at risk. From satellites to power grids and communication networks, everything could be wiped out by the electromagnetic pulse, or EMP, that would accompany the supernova radiation. If you've ever seen the effects of an EMP, you'd know how devastating it can be for electronics. Our world runs on electricity, so nothing would escape the chaos. Phones, computers, medical equipment, and communication systems could all fail at once. If the EMP is strong enough, humanity could suddenly find itself pushed back into the Stone Age because of Betelgeuse. What's worse is that the effects wouldn't disappear quickly. Experts predict that the bright light from the Betelgeuse explosion would stay in our skies for several months, and the radiation and shockwave effects could last just as long. Keep in mind, these predictions are based only on what we currently know. The universe constantly reminds us how little we truly understand. Every decade, astronomers and physicists discover new cosmic truths that once seemed impossible. That means the aftereffects of Betelgeuse's explosion might be far beyond what experts have suggested so far. For instance, the aftershocks and radiation could pick up particles, asteroids, and other harmful subatomic elements in space and fling them toward Earth. They could accelerate the speed of asteroids already on a collision course, making an impact with our planet far more dangerous. Cosmic rays, which are high-energy charged particles, could also be supercharged, posing severe radiation hazards to astronauts and satellites orbiting above Earth. The truth is, the uncertainties of cosmology leave a wide margin of doubt in scientific predictions. For all we know, Betelgeuse could explode within the next 100 years. And if it does, some of the aftereffects will almost certainly reach us in one way or another. That's the reality of the complex and unpredictable universe we live in. Have you ever wondered how the light from stars, or in this case, Betelgeuse, actually reaches us here on Earth? Just like every other star you see in the night sky, Betelgeuse's light has traveled the entire distance across space to reach our eyes. But when it comes to a supernova blast, no one can say for sure if the same will happen. Only time will tell. Thank you for watching another episode. While you're still here, click on the video on your screen to see more mind-blowing videos like this one.